This is 4.1 sensation. The objective for this, I think, is really important, and I think will help you kind of have a better understanding of sensation. The objective for this lesson is to describe the general principles of organizing and integrating sensation to promote stable awareness of the external world. So it's essentially how our senses, or how we make sense of our senses and our sensations, to have an awareness of what is going on around us, and that then in turn impacts our behavior. Sensation and perception, the basic principles. Sensation means sensory receptors process stimuli in our environment. So for example, smell, temperature. And then perception is how do we interpret that information. So we all smell the same thing. Some people may say it smells good. Some may say it smells bad. Some may be hot. Some may be cold. Then what happens is what we call sensory transduction. So this is where we take that stimulus, that smell or sight or sound or taste, so any of the sensations, and then it gets converted into what we call electrical signals. So remember, we're talking about neurons, we're talking about nerves, we're talking about sensory neurons, and we're talking about motor neurons then eventually. So these sensory neurons is what we're talking about with the sensory transduction. You take that sense and it converts it into electrical, because remember, neurons are electrical, and that is what allows us to process that information. And these two things work together, sensation and perception. This is how it impacts our behavior. So we have two ways of looking at it. The first way is bottom up, which is where we first sense things and then our mind processes it, or mind first, and that might set expectations. That's called top down. So if we take a look at this image on the right, bottom up, I would ask you just to tell me what you see. You might see trees or a horse or a man on a horse. That's bottom up. You are giving me your basic sensations first. Then if I were to tell you there's actually faces hidden in this picture to the right, that's mind first. So I'm kind of giving you an expectation, and then you're using your senses to process that. So you might take a look over here to the right. You can see kind of a face right here. There's a face right here. There's a face right there. There's multiple faces in this. And now that you see that, there's one right back there. Now that you see that, you see the faces first, and that's called top down. To continue on with perception, we have what we call Gestalt theory. This is where we integrate pieces of information into meaningful wholes. So this is how our mind is able to fill in the gaps, if you would, if we are not presented with all of the information. And Gestalt, the way it's written here to the right, is a perfect example of that. The first is closure. If we're not giving all the information, our mind automatically fills it in. The second is proximity. If things are close together, we assume they are together. Continuation is the third. That again, if things seem to be continuing, like the S seems to be continuing or the line down the middle seems to be continuing, we assume that it's together. Similarity, things that are similar, we assume to be the same. Figure ground. So figure ground is when an object stands out. So for example, if we take a look at the A right here, as soon as I say that there's a tree right here, that tree is going to stand out from the background, and that's going to be your figure ground. Perceptual organization, the way that we organize our information once we have that information. So depth perception is what creates a three-dimensional world for us. It allows us to estimate how close and how far things are. What you have up here on the right-hand side with the baby walking across that clear box is what we call the visual cliff. What we did, or Eleanor Gibson did, was a study with newborn animals and infants and found that at 6 to 14 months of age, infants can start to perceive depth. I know it's kind of a big age gap, but the more important is that it starts very young. So at a very young age, infants understand depth perception and would no longer crawl across that box. When it comes to depth perception, there's two types of depth perception. The first is binocular cues, and this is where you need two eyes to see depth perception. And we need this because of retinal disparity. So we haven't talked quite about vision yet, and I know that, but the way vision works is it projects images on the back of your eye, what we call the retina. And when that happens, we compare images from both retinas all the time, and it happens consistently. And when we see depth perception, where you need two eyes to see it, then that is because of retinal disparity, meaning that you need retinal disparity in order to see that. So things like 3D movies. Monocular cues is depth that we can perceive with one eye alone, and those are all examples off to your right. So it doesn't matter if you have two eyes open or one eye open, you're still going to understand occlusion, relative size, when things cast shadows, distance to the horizon, shading, texture gradients, and linear perspective. All gives you the illusion of depth perception without there actually being depth there. And those are all the examples off to the right. When it comes to sensation, we have what we call thresholds. The first is the absolute threshold, and this is the minimum amount of stimulus that you're aware of at 50% of the time. Use the chart over to the right for an example of this. When it is pitch black, 50% of the time, people with good vision can see a candle flame 30 miles away. Hearing, you can hear a watch ticking 20 feet away, again, if it's silent. You can hear that 50% of the time. Smell, a drop of perfume in a 6-room house. Taste, a teaspoon of sugar and a gallon of water. And touch, a wing of a fly on your cheek that's been dropped 1 centimeter. So that's kind of the basic minimum that you need as a human in order to sense something. Signal detection tells us how and when we will detect a faint stimulus. So there might be times where you're paying attention, so your signal detection may be more accurate than others. If it's really quiet, if you're aware of something that might happen. Signal detection is saying that there really is no absolute threshold. It really just depends on the person and the situation. So absolute threshold is saying that 50% of the time you're going to notice this stuff. Signal detection said that's not accurate. It really just kind of depends on the situation and the person on if or you will discuss or if you will detect that stimulus. Difference threshold, or also known as just noticeable difference, those two things can be interchangeable, is the amount of change that we can detect. So if somebody puts on more perfume, at what point are you going to notice it? If someone adds more sugar to your sweet tea, at what point are you going to notice it? If you're holding on to something heavy and then they add more weight, at which point are you going to notice it? And so what happened was Ernest Weber came up with an idea called Weber's Law. And this says that it really depends on a percentage, not a number. So it depends on a percentage of increase. So like, for example, you increase perfume by a set percentage. You increase weight by 20% and you will notice a difference, which makes sense because if you're holding on to 100 pounds and you add 1 pound, you may not notice that. But if you're holding on to 100 pounds and you add 20 pounds, you're probably going to notice that difference. So Weber just said it's not a number, it is a percentage of a change. So the idea is if you pair two similar stimuluses together, can you tell if they're different? And that's what Weber was trying to figure out. And finally, when you don't notice a difference is when you have sensory adaptation. It's when you become less sensitive to the unchanging stimulus. So let's say you are baking cookies in your house or somebody's baking cookies. When you first walk in the door, you can smell that. Maybe after being in the house for an hour or two, you don't notice it anymore, and that's because of sensory adaptation. You're no longer sensitive to that change. And that is it. So think back then to the objective for today and how this information allows us to make sense of our environment and how these sorts of things may impact our behavior or impact the way that we do things Are you detecting everything you're supposed to? Are your sensations working accurately? Are you interpreting those sensations the same way as the person sitting next to you? Are you hot? Are they cold? Do they think it smells bad? Do you think it smells good? All of these sensations can impact our behavior and the way that we do things.